For this experiment, I'm going to do a reaction with sucrose and water. Sucrose is just table sugar. Formula C12H22O11. What I did was, because I don't have a scale in grams, I have milliliters. I took the density of sucrose, which is 1.59, and I times it by 100 milliliters, which is how I measured my sugar. 100 milliliters. Wait. And then I multiplied it by the density to get the number of grams. So, by having 100 milliliters of measured sugar, I have 159 grams of sucrose. If I divide that by the molecular weight, I get this many moles of sucrose. To have a one-to-one reaction with no leftover reagent, and that they will hopefully react perfectly, I have to use the same number of moles of water to get a one-to-one mole ratio. I take the number of moles is equal to x grams over the molecular weight of water, and I get 8.36 grams of water, which is the same as milliliters of water because the density of water is 1. This is a 10-ounce cup. I measured the whole thing out to be 9.5 centimeters. And when you do the conversion factor, there is 0.3 ounces and 8.36 grams, which is the amount of grams I get using this number of moles. I just divided the sections of the cup by 10, and because there's 0.3 ounces, it's also equivalent to 0.3, which is 30% of the whole cup, which is this line right here. So if I add this much water with this much sugar, there should be a 1-to-1 mole reaction and no leftover reagent. So let's see if that happens. So I pour this in. I'm going to pour this in here. I'm going to stir it up. And as we can see, there are no clumps of sugar left over. There's a few drops because the measurements aren't perfect. But for the whole scheme of things, we have a 1-to-1 mole ratio reaction with no limiting reagent. Therefore, all amounts of each product should have reacted, and there's no leftover clumps of sugar or clear water. Hence, we have a perfect 50-50 solution of sucrose and water. And that is my stoichiometry reaction.